Hey guys, it's Miss De Los Reyes. Today we're learning about inverse functions. Is f of x the inverse function of g of x? The easiest way to determine if two functions are inverses of each other is by checking the table. So in your graphing calculator, go ahead and type in the f of x function into the y equals so that you can look at the table. And for the purpose of this example, I'm only going to jot down the integer coordinate points. So for example, -1, -3, 2, -2, 5, -1, and 8, 0. Okay, now I'm going to go back to my y equals and I'm going to enter in the g of x function so I can get another table of values. So I'll type in 3x plus 8, check my table. Now, when I'm checking my table, this is what I'm looking for. If f of x is the inverse of g of x, this point, -1, -3, should reverse. So x equals -1, y equals -3 switches, and now -3 is the x and -1 is the y. I'm going to go ahead and list all of my y values as my x values, and what I'm looking is that all of my corresponding x values will now become the corresponding y values. This is what I want for it to be an inverse. I look at my table on my graphing calculator and I check. When I look at the table, I see that -3 equals -1, -2 equals 2, -1 equals 5, and 0 equals 8. So yes, these are inverse functions. Okay, let's try to figure out if these two functions are inverses. So the f of x table and I'll start with -3, -2, -1, and 0. And the corresponding y values are 1, 2, 3, and 4. And now I'm going to look at the g of x table. So I'm going to put the g of x function into my calculator. And I want my y values to become my x values. And I'm hoping that the f of x x values becomes the g of x y values. So these should reverse if they are inverses. So now I check on my table and I see that here, so what I actually have, this is what I want, what I actually have on my calculator. When I look for 1, I see that it equals -1. When I look for 2, it equals -2. When I look at 3, -3, and 4, -4. So no, they are not inverses. Because remember, the x and the y values should trade places. In this problem, it's asking to find the inverse function. Instead of having to go through and look at the table for each given multiple choice equation, I'm going to write my own inverse function. So here's how you do it. You have y equals x minus 6. To find the inverse, we are going to trade y and make it x, trade x and make it y, and we're going to put this little notation here, this -1, that means inverse, minus 6. So now we are going to solve for the inverse. So in order to do that, I'm going to cancel plus 6. And now I get the inverse of y is x plus 6. So again, to recap, I traded out my y and x values and replaced them with x and y values. Then I solved. Okay, let's try it with this problem. Find the inverse of the function. So the original function is y equals 3x minus 2. I'm going to switch, and when I switch it, I'm going to write the inverse y. And now I'm going to solve for inverse y. So I'm going to add 2 to this side. So that's x plus 2 equals 3 inverse y divided by 3. So I get 1/3 x plus 2/3 equals the inverse of y. Okay, so now let's look at inverses with a table. The function f of x is invertible. Invertible means has an inverse. So this is asking, this right here is the f of x function. What I want is the inverse table. The inverse table will be the same table, but all the x and y's will switch. So I'm going to start out by writing all my y values down as x's. And honestly, just for this example, I'm going to show you the entire table. So here I'm asking for, on the inverse function, when x is -6, what is y? Y is -2. What you could have also done is looked at the original table here, and if we are switching x and y, instead of focusing on the x value that is typically on the inside, I'm going to focus on the y value. So this is the y. Therefore, its corresponding point is -2. Therefore, its corresponding value is -2. So right here in this table, I'm looking for 70 as the y, and therefore its corresponding value is 71. When you're looking at functions as a graph, you want to look for the specific points. So in this problem, I'm asking, on the inverse, when x is 9, what is y? In order to figure that out, I have to first find the original point when y is 9. So I'm going to go to 9 on the y. I'm going to go to my graph. So here's 9. I'm going to go to my graph. So that point there is 4, 9, which means the inverse is going to be 4. Okay, let's take a look at this one. So the inverse function of -7. Normally we say -7 is the x, but since this is the inverse, -7 is the y. Right here, I go to my graph, and on this graph, the point is at 5, -7, which means the inverse is -7, 5. So my value is 5. All right, the graph below shows a function. Is its inverse also a function? Well, there's a very specific way you can determine this. When we were determining functions, on the original function, we would tell if it was a function by using the vertical line test. The vertical line test is where if you made a vertical line, if the graph touched the vertical line just one time, then it was a function. So if it touched one time, then yes, it was a function. If it touched more than once, then no, it was not a function. Well, when you're doing the inverse, instead of doing a vertical line test, we're going to make a horizontal line across our graph, and we're going to look. Does the graph touch our line one time or more? And if you look, it touches more. So, is its inverse also a function? No, it is not. Let's take a look at this graph. Is its inverse also a function? We're going to make a horizontal line, and we're going to see how many times does a graph touch the horizontal line. In this case, it only touches once, so yes, its inverse is also a function. Thanks for watching. Bye!